How do you find the LCM of different numbers using the easiest and most efficient method, prime factorization? Let's find out. Hello everyone and welcome back to another math lesson in Mathies with Miss C. In our last video, we learned the basics about LCM and what it actually means. Make sure to watch that video linked in the description box below. Today, we're going to get into the stuff that really matters. How do we actually calculate the LCM in a way that no matter what numbers we get, we won't have any trouble? So let's begin, and what better way to do it than with an example? Now we have to find the LCM of the numbers 15 and 20. Write 15 and 20 side by side and make the lines we always make for prime factorization. Now, if you remember HCF correctly, you would remember that when finding the HCF, we would only divide it by the prime number that divided all of the numbers. But with LCM, if a prime number divides any of the numbers, we're good to go. So of course, we're going to try dividing it by the smallest prime number, which is 2. Even though 15 can't be divided by 2, 20 can. So we will write 15 as it is and divide 20 to get 10. Now we're left with 15 and 10. Are either of the numbers divisible by 2 again? Yes, 10 still is. So we're going to divide 10 by 2 and get 5. Once again, we'll write 15 as it is and write 5 next to it. Now neither of the numbers we have can be divided by 2. So let's move on to the next prime number, which is 3. 5 can't be divided by 3, but 15 can. So that's exactly what we're going to do. Remember, if any one of the numbers can be divided, we are going to divide it. 15 divided by 3 is 5. The other 5 will remain as it is. Now we're left with 5 on both sides. Since 5 can't be divided by 3, let's move on to the next prime number, which is 5. Now this just became really easy. We have 5 on both sides and we have to divide them by 5. After doing this, we're going to be left with 2 ones at the bottom. And that is exactly what we wanted. Another point to remember here is that when we are doing HCF, we only had to keep dividing until we ran out of prime numbers that could divide both. But with LCM, we have to keep dividing the numbers until we get to all ones at the bottom. And here we have done that. The last step is to multiply all the prime numbers we wrote on the left. In this case, that will be 2, 2, 3, and 5. So we are going to write down that the LCM is equal to 2 times 2 times 3 times 5. And that is equal to 60. So the LCM of 15 and 20 is 60. Now let's move on to a trickier problem where instead of 2 numbers, we have 3. These are 22, 8, and 4. Let's begin by writing 22, 8, and 4 side by side and making our lines. We are going to start by our favorite number 2 because not 1, not 2, but all 3 of these numbers can be divided by 2. 22 divided by 2 gives us 11, 8 divided by 2 gives us 4, and 4 divided by 2 gives us 2. Now, can we divide it by 2 again? We most certainly can, because 4 and 2 are still even numbers. So 11 stays as it is. 4 is divided by 2 to give us 2, and 2 is divided by 2 to give us 1. So now we have 11, 2, and 1. Let's try 2 one more time, since the number 2 can still be divided by it. So the 11 stays as it is. 2 divided by 2 gives us 1, and the 1 stays as it is. Now we are left with 11, 1, and 1. So 2 out of the 3 numbers have finally reached 1. Now we're only left with the number 11. If you learned the list of the prime numbers I shared with you guys before, you wouldn't need to divide 11 by 3, 5, or 7 because you would know that 11 is a prime number itself. So it can't be divided by anything else. So now we are going to divide this by 11. 11 divided by 11 gives us 1, and the other ones stay the same. Now we've finally reached what we wanted. 1, 1, and 1 at the bottom. And remember, for LCM, we always keep dividing until every number becomes 1. Now for the last step, multiply all the prime numbers we wrote on the left. So the LCM is going to be 2 times 2 times 2 times 11. And that gives us 88. And there you have it. We just learned how to calculate the LCM of 2 and even 3 numbers using the prime factorization method by dividing them all side by side. Now it's your turn. Try finding the LCM of 12, 16, and 20 using the same method and share your answers in the comments below. I would love to read them and help you out if you have any questions. If this video helped you understand how to calculate LCM, don't forget to like, share, and subscribe to the channel for more math lessons. In our next video, we're going to learn how to solve LCM word problems, so stay tuned. Remember, don't hate math, keep practicing, and I'll see you in the next video. Bye for now.